All right, yes, we're live. We are going to start with another notebook. Uh, just titled Ray Tracing. And yeah, I guess we'll be practicing patched matrix operations in PyTorch uh, by writing a basic graphics renderer. I guess we'll also look at using AI systems to learn and code, some type checking, some good practices, debugging, and other stuff. Um, so for today, I plan to just do race and segments. Um, I think this should be a simple uh, and short live stream. So yeah, so let's just dive into this. Okay, all right. Mm-hmm. So yeah, here we are. Start off with 1D image rendering. We have a camera. It'll be a single point at the origin, and there's a screen at x equals 1, just parallel to the YZ plane. And the objects are made of triangles. Triangles are represented as 3 points in 3D space, 9 floating points. Hmm. So a ray represented by 2 points, origin and direction. Oops. And yeah, it extends indefinitely in one direction. So right now we just have bright or dark based on if the ray hits a particular pixel on the screen. And to start, we let the set dimension space be 0 and work in the remaining 2 dimensions. Okay. So implement the following functions. I generate some rays coming out of the origin. Right. Num pixels. While limit. From so start off by uh, initializing rays, and eventually we're gonna do some changes to it and return it, and can start off with all zeros, and the shape should be, well, the number of pixels, and per pixels we have 2 points, the origin and the direction, and each point is made of 3 coordinates, x, y, and z. If you observe this, we are basically done. Uh, we're basically half done. Just need to fill the second point for each ray. The direction, the point that represents the direction in which the ray is extending. And about this, the function says should be at x equals 1. So we already know what the first coordinate of the direction should be. Uh, Rays for all pixels, and make this 1. Basically, for all pixels, for the second, for index 1 point, make the first coordinate 1, because you want the x equals to be 1, and that's where our screen is. I think it would broadcast correctly, and this would be, I need to generate uh, n numbers starting from minus y limit to plus y limit. So I think, yeah, start would be minus y limit, steps would be, oh, end would be y limit, steps, right, steps would be in num pixels. This should work, right? Guess it did. So we have our x, we have our y, we have the screen at x equals 1, and we see evenly spaced rays. Yeah, let's look at the solution. Yeah, initialize the rays. Oh, okay, do this. Hmm. Good to know, good to know. Uh, let's move on. Right, so I guess we don't want to create new storage, so we can pass this view that's writable. Hmm. All right, let's look at this. Suppose we have a line segment defined by points L1 and L2. Then for a given ray, we can test if the ray intersects the line segment. Okay, assume both are infinitely long. Solve for their intersection. If the point exists, check whether the point is inside the line segment and the ray. Makes sense. You can write the equation for all points on the camera ray as R of V O plus V. Makes sense. You can start from 0 and in the direction of t, you can move any amount of distance. So that's the offset v times t is calculating. So these are all the points on the camera ray, and these are all the points for the object line. Let's say L1 plus V minus L2 minus L1. Hmm. Ah, okay. Hmm. Yeah. So I change. Oops. What I don't understand is, okay, this is the line segment defined by L1 and L2, and the green dot basically tells you for different values of V, right? So the orange points are L1 and L2, and the green point is basically telling you where all the set of points generated by this parameterization lie. Um, and setting the line equations from the above equal gives the solution. Makes sense. Um, I want to make sure we hit this point home. Let me draw it up. So for race, right? So what we have is we have origin, and we have some direction. So this is D, and we need all the points here. And you can get all the points by simply doing O plus U times D. If origin was really uh, 0 comma 0, then we wouldn't need this. But since it could be anything, we need to make sure we add the offset to this. And since we only care about, uh, since the ray only extends infinitely in one direction, we need to have this condition to make sure we get only points on this side of the 2D space. Now for line segments, suppose we have a line segment defined by L1 and L2. So L1 and L2 can also be thought of as vectors starting from origin. This is not the same as this. I'm talking about 0, comma 0. So if you think of it them like that, how can you generate now the points along this line? That would be basically L1 plus, I guess there are multiple ways to write this. So if you look at what L2 minus L1 is, you can get L2 minus L1 by taking L2 and taking L1, flipping the direction. So if you do this, you get minus L1, right? So L2 minus L1 is simply this. No, it's simply this, but this. Wait a minute. So you need to move this vector. Let me just do that. Oops. Hmm. Yeah. So if I move this line as is here, get something like this. So get some point here. This is what the L1 times L1 plus V times L2 minus L1. And if I have something like this, let's do something very trivial. Let's say this is L1, so this is L2, this is L1, this is minus L1, and L2 minus L1 would be this is L2, L2 minus L1 would be this. And if you subtract, sorry, if you add to L1 some V times this, right, so you have a vector in this direction. Let me just make this bigger. So yeah, let's go back to our previous example. Say we have L1, say we have L2, then minus L1 would be something like here, and if you were to add L2 minus L1, it would be somewhere here. So this is L2 minus L1, and if you take this direction, this is same as this direction, and if you take fraction of that, that is you either take 0% of it, which means v is 0, or you take 100% of it, which means v is 1, and or it can be anywhere in between. So we want v to be in 0 comma 1 interval. So this will give us sort of all points on this line segment. So if we want to know if a line segment and the ray intersect, all we need to do is check if minus L1 is equal to, yeah, CUD. We know everything here. U and V are the unknowns. Check if they have a solution such that, well, U is greater than or equal to 0 and V lies in between 0 and 1. So I guess that's what we have here. Now if you just yeah, if you just try to uh, write the vectors, they're 2D space, they're all two-dimensional vectors. If you just expand them and separate them into linear equations, then you get this. Yeah, and just solve for u and v and check if u is non-negative and v belongs in 0 comma 1 interval. Okay, so let's now, yeah, I guess this is the last one for now. So let's implement intersect ray 1D 20-25 minutes. It's fine. So yeah, using torch, linear algebra, solve torch stack, implement the intersect ray 1D function to solve the above matrix equation. Is it possible for the solve method to fail? It can fail if there are no solutions. So yes, it's definitely possible. Sample input, come to that later. Let's worry about the happy path now. Yeah, so what was the equation? So let's extract origin and the direction from ray. Can do this by ray of 0, ray of 1, and L1, L2. Right, so now we need to stack uh, yeah, if you think of this as like x equals p, then a b, let's do b first. B would be L1 minus O, right? Yeah, I guess we can ignore the z coordinate. Hmm. Okay, so we can do this. And A would be, right, we need to stack two things. We need to stack P L1 minus L2. We need to stack them along. Wait a minute. So I think we are concatenating them. This. So you want to solve A, B, Uh, one thing I'm not sure about is this, and we also have to handle the case where solve can fail. Uh, let's verify this first. Uh, yeah, let's do. Let's say D was 2,3, was 1,2, was 1,5. So I want my answer to be something like uh, 2 comma 0 and 3 comma minus 3. Let's see. Yeah, makes sense. So now we just need to handle the case where it fails. I'm sure there's something about it in the documentation. Let's open the docs. Yeah. Hmm. So I guess it raises a runtime error. And how do I catch that? Try. Maybe we should just run it and see. Can afford to do that. Okay. Guess it's hmm. Okay. Adding type-ins is a good thing. Help documentation, improves the behavior, the ID, get good code structure out of it, makes debugging easier. Hmm. Hmm. Uh, checks typing. How do we enable runtime type checking? That seems most useful. Oh, my bad. Stop. Okay. Uh, All right. So yeah, I guess that's it for now. It's a short stream. I've got some other stuff to get to. We'll see in the next stream where we'll go over patched operations.